Doing well today. I just want to work an example here. It's actually from a previous video. It got cut off, so I'm going to add it back on. A ball weighing 0.75 pounds is thrown vertically upward from a point 6 feet above the ground with an initial velocity of 20 feet per second. As it rises, it is acted on by air resistance equal to V over 64 pounds. How high will the ball rise? So basically what we're going to employ here is Newton's second law, which will be the sum of the forces in the y direction will be equal to the mass times acceleration in the y direction. So what we're going to do is we're going to find our axes here. X is this way, positive y is this way. And then we have two forces acting on the ball. Gravity, which is going to go down, and then air resistance, which is going to go opposite the ball, which is negative kV. So this is your air force due to air, and this is your force due to gravity. So MAY is going to be equal to negative mg minus minus kV. But AY is just derivative of velocity, so V of t is going to be the velocity at time t. So m times dv dt is going to be equal to negative mg minus kv. Now, what do we know? We know the weight mg is equal to 0.75 pounds, and g is 32 feet per second squared, so m is going to be 0.75 over 32. So that's going to be m is 3 over 128, what we call slugs. So m is 3 over 128 slugs. Let's see, up here we know k is going to be 1 over 64 from the information v over 64. So k is going to be 1 over 64, and mg we know is 0.75, so I think we're good to go. So this is going to be our differential equation, and our initial velocity v of 0 is 20 feet per second. Make sure everything's in the right units. Make sure everything's in feet if we're starting in feet, seconds, pounds, etc. So we're good to go. We got our differential equation. So we can say dv dt equals negative g minus k over m v. So that's true because of, let's see, I'm dividing through the differential equation by m. So what I'm going to do is substitute in, I'm going to say that dv dt plus k over m, well that's going to be 1 over 64 over 3 over 128. V equals negative 32. So that's going to be the differential equation dv dt plus 2/3 v equals negative 32. Now we use the integrating factor to solve. So the integrating factor is going to be e to the integral 3, let's see, is it 3 over 2? I think it should be 3 over 2. Sorry about that. Did quick math, always a mistake, always, no, 2/3. 2/3 is right. So 2/3 dt, so that's going to be e to the 2 over 3 t. So that's our integrating factor. So then we know it's going to become d by dt of e to the 2/3 t times v equals negative 32 e to the 2 over 3 t. Now, integrating factor means integrate both sides with respect to t. So integrate both sides with respect to t, we'll get e to the 2/3 t times v equals negative 32 times 3/2 e to the 2/3 t plus c, which means it's going to be v equals negative 48 plus c e to the negative 2/3 t. Now we know v of 0 is 20 feet per second. So v of 0 should be 20, which equals negative 48 plus c e to the 0. That tells us c equals 68. So v of t is negative 48 plus 68 e to the negative 2/3 times t. Now that's our velocity at time t. What we want to know is how high does the ball travel? So how high does the ball travel means the velocity is going to equal 0 at the top of the path. So set v equal to 0 and solve for t max height. So 0 equals negative 48 plus 68 e to the negative 2/3 t max height. So that's going to tell us that 48 over 68 equals e to the negative 2/3 t max height. So then take the natural log of both sides. So natural log of 48 over 68 equals negative 2/3 t max height. So t max height is going to be negative 3/2 natural log 48 over 68, which is going to be, let's see, if you work that out, it turns out to be like 0.5225 seconds. So it's going to be 0.5225 seconds. So not very long, actually. Very quickly after it's thrown, it reaches its max height. So it actually can't go that far based on what we've got. So we've got our velocity. Now we want to know how high above the ground does it go. Well, that's the position with respect to the ground. So s of t is going to equal the integral of v of t dt, which is going to be integral of negative 48 plus 68 e to the negative 2/3 times t dt, which is going to be negative 48t plus 68 times negative 3/2 e to the negative 2/3 t plus c. So now using our initial condition, I guess we could simplify first. So this is our position above the ground at time t. So this is going to be negative 48t. Let's see, that's going to be minus 102 e to the negative 2/3 t plus c. So s of t. And what do we know? We know s of 0. It starts out 6 feet above the ground. So 6 equals negative 48 times 0 minus 102 e to the 0 plus c. So we could say c is going to be 108. So our position function, s of t, is negative 48t minus 102 e to the negative 2/3 t plus 108. So that's our position function, and what we need to do is take the max height up here, plug it into our position function, and we'll get the max height. So max height will be s of t max height, which would be negative 48 t max height minus 102 e to the negative 2/3 t max height plus 108. And we get that that's about 10.9238 feet. So it only goes about 4 feet above where it started. So it's a pretty light ball, and it's only going about 4, maybe 5 feet. I guess about 4 and almost 5 feet above where it started. So either something is throwing it that's not very strong, or maybe someone like a child, or how are they starting 6 feet above the ground? I don't know, but some kind of thing is throwing this up from 6 feet off the ground, but it doesn't go very far. So that's the problem of throwing the ball up and using the sum of the forces basically to set up your differential equation and then solving it.